Welcome to our episode 9 of our JEE Main 2026 series. Here is our question 9. The smallest positive integral value of a for which all the roots of this biquadratic equation are real and distinct is equal to which of the following options? This is an absolutely brilliant problem because it contains a classic quadratic disguise trap. Most students will see this biquadratic equation, substitute t equal to x square, apply d greater than 0 because it has real and distinct roots, and confidently jump to the wrong answer. The sharp move here is realizing that d greater than 0 is necessary but not sufficient on its own. The nature of the substituted roots matters immensely. So let's break down this question. The given equation is x to the power 4 minus ax square plus 9 equal to 0. And whenever you see x to the power 4, x square, constant with no odd powers, alarm bells should ring immediately. Because this structure is screaming, let x square equal to t, and the terrifying biquadratic equation becomes t square minus at plus 9 equal to 0, and that looks quite manageable. Now this equation must have two distinct positive values. That means two distinct positive roots. Why? Because the question doesn't ask just for real roots. It asks for all real and distinct roots, which means we need 4 real and distinct values of x for this original biquadratic equation. So what must be true about the roots of our new quadratic equation? Let's say t1 and t2. So if the root t is negative, like let's say t is equal to minus 4, then x square becomes minus 4, which means x square is negative, which means x becomes imaginary. Now let's say if a root t is 0, then x square becomes 0. That means x is equal to 0, 0 repeated roots, so not distinct. Therefore, both the roots t1 and t2 must be strictly positive and distinct, which means t1 and t2 must be greater than 0, strictly positive, and t1 is not equal to t2. So for both the roots of t square minus at plus 9 equal to 0 to be positive and distinct, we must satisfy 3 simultaneous conditions. Condition 1, where the discriminant for distinct roots, that is d, must be greater than 0. Now discriminant is given by the formula b square minus 4ac. Now here a is 1, b is minus a, and c is 9. So b square minus 4ac, let's put the values and we get minus a square minus 4a into c greater than 0. So which gives me a square minus 36 greater than 0. Now a square is greater than 36, which means modulus a must be greater than 6 when we take square root on both sides. Square root of a square is modulus a. Now we are looking for a positive integral value of a, which means a has to be greater than 6 because modulus a is equal to a if a is positive. Now the second condition, which says sum of the roots must be positive because both the roots are positive. So their sum must be positive. B is minus a, so minus b is equal to a by 1, which is a is greater than 0. And the third condition, product of the roots, which is c by a greater than 0. C is 9 by 1, that means 9 is greater than 0, and this is always true for whatever be the value of a. So intersecting our conditions, a greater than 6 and a greater than 0, we get the final valid range for a. That means a must belong to 6 to infinity. That means a must be greater than 6. Any value which is greater than 6 will automatically be greater than 0. Now since the problem asks for the smallest positive integral value of a, and we have got a must be strictly greater than 6, so it cannot be 6 itself. So the next integer is 7. So the correct option for this question is option 7. In JEE, always check what your substitute variable is doing behind the scenes. If you caught that boundary trap, drop a thumbs up in the comments. Subscribe to Think Sharp Alley, and I'll see you in question 10 with another massive shortcut. Until then, stay sharp.